Okay, thank you very much. Thank you for the organizers to invite me for this first meeting. Let me share my screen and then start my presentation. Hope you can all see it. Is it correct? Yes. So I would like to present to you, the aspect of multi-hazard risk assessment. We have seen in the previous presentation also that you can explore an area, whether it's exposed to multiple hazards, but we would also look in this one how hazards happen at the same time in space and overlapping as well, and how that gives additional problems. And that's also why we make this particular project, this study. If you look here to the right, the map of the world map with the main disasters coming from a reinsurance organization, Munich Re, you would see a number of these events that are hurricanes or earthquakes. They are often presented as single events, but in fact, they are a whole combination of different problems. A tropical storm in an area might be accompanied by extreme wind, extreme rainfall, causing also landslides and flooding. The wind causes wind damage, but also storm surge, and all these hazards interact with each other. Others might actually happen in different time periods shortly after each other. So we consider hazards not by themselves, but also by their interrelationships. First of all, how they would occur, whether they are having a relationship in terms of the triggering, or whether they occur in a cascade, like one event triggers another one, etc., or whether they amplify each other. So, for example, a wildfire might cause more flooding if the rainfall happens afterwards. And so we're looking also at spatial relationships, whether these events overlap partially or not. And also quite important is we look at the temporal relationship. Are these events, even though they might be the same or different, are they actually separated in time, happen independently from each other, or they might also happen shortly after each other, as illustrated in the figure, that they might actually, one might occur while the recovery from another event still is going on. So they, what we call consecutive events, or they might occur simultaneously. These would have quite different impact in terms of the effect that they would have. However, disaster statistics are often being treated still as individual events. Say there are some major disaster databases in the world, like the EMDAT, the Global Disaster Database, or Des Inventar, which is like the bottom-up type of database. They are basically storing information as individual events. And studies have been done, for example, by our colleagues from the Free University of Amsterdam that looked at these EMDAT data, and they discovered that at least 40% of them are multi-hazard events based on an overlap of 50%, and that they would occur within 3 months of each other. Another study done by colleagues from Strathclyde in the UK, showing in the map here above, also says then, well, if they are multi-hazard events, what kind of relationships do they then have with each other? And so there's a lot of them have these triggering aspects or preconditioning aspects. Others are, say, spatially compounding, so they happen at the same place and worsen the situation, or they're temporally compounding, so they might happen at different locations, but put stress on the emergency system. So these is a relevant aspect to consider. And so we are looking at this multi-hazard risk component, where we are breaking that up into individual sections. We have the hazards as such, what are their interactions, their spatial relations, and the frequency. But we also have the assets on the other hand. What are their types? What the spatial entity are? How do we characterize them? The interaction between the two, a hazard footprint and assets like buildings or land use, is exposure, and the degree of damage would be obtained through vulnerability curves. And then we would be able to say something about the expected losses. Of course, these would be the quantitative component, but often they are combined with indicators to represent other dimensions of vulnerability and capacity, and they would lead to information that would be the basis for risk reduction planning. Then this system is also dynamic. It changes over time due to climate change and land use change. So there's a lot of different terms being used here. You see a number of examples of terms that are actually being used in literature to reflect the multi-hazard risk component, but calling it differently. Say they also kind of increase in severity, going, for example, to systemic risk, which is a risk that also puts a whole system in danger. So that is so severe, it threatens the functioning of a system like transportation system, health system, or so. Existential risks is even worse than that. Right, you see an example of one of the main multi-hazard examples I could think of, the earthquake in China in 2008. There's a lot of efforts now focusing on multi-hazards. Here, just a number of examples of current EU projects that are trying to address this, changing multi-hazards in a changing climate. One of them is the Paratus project. It is a project that aims to develop an open and online user-centered platform for systemic risk assessment. It is done by a group of 19 partners that represents research, industry, local authorities, end users, and NGOs, and works in 4 case study regions with very different problems. Mega city Istanbul, a very earthquake-threatened city Bucharest, cross-border transportation in between Austria and Italy, and Caribbean islands, small island development states. So within this project, we are aiming to learn from past events to give guidelines on how to better develop databases for these complex disaster events and learn them through forensic analysis and impact chains. And we use also remote sensing data to better characterize changes over time and to predict them in future with trend analysis. We try to analyze the risks and also quantify their uncertainty. And then we're trying to develop tools for adaptation. So we're using mitigation measure options and to see which mitigation measure would be most optimal to use in which situation. And we also use serious games as an option. We bring it together in a platform for systemic risk analysis. We also link it with other projects. So we are working with projects in the global south on small island development states. We work with DG ECHO projects that look at, disaster events in other countries. And so our platform that we aim to develop is very simplified, looks like this. We have 2 major components. The one component on the left side is a information service component, where we are trying to bring together different information sources that would be relevant for stakeholders. Our stakeholders are not directly the general public, as was in the example of the geo risks. We are targeting to decision makers on risk reduction. So those could be first, second responders, planners, and so where they get the information to make those decisions, So we bring that together in a kind of information service component. And on the other hand, we have on the right side, we provide a number of tools that help stakeholders develop their own scenarios and alternatives for risk reduction based on their own particular situation. So these have a series of tools that will be developed in a web-based platform. We're also trying to link that up with information from other EU projects. So we're currently discussing that to see if we could actually team up. So to have like that, a better representation of information already brought together in single platforms. One of the platforms that I could mention here is called the Disaster Risk Gateway, developed in a sister project, but we are looking at how we could actually combine. And that already brings together a lot of resources related to multi-hazard risk assessment. So within a project like us, we have frequent stakeholder interactions. We do quite a lot of workshops, and we have individual consultative meetings to understand the way of working, to co-develop impact chain. So what would be what have been the sequence of impacts within their area, and also to get feedback on the tools that we develop. And we use that also to improve our scenario development and serious games, and also for participative decision making. So one of the key tools within our platform are impact chains. And these are a graphical representation to better understand how disaster events, multi-hazard events evolve, how they interrelate in terms of hazards, but also how the impacts cascade through different sectors of a system. And so we are trying to develop those as a kind of a mind map in consultation with stakeholders. And we develop these kind of tools. I'm sure it should be possible to move to the next, yes. In a simplified way, it could look like this. This is a very schematized one that shows, for example, in impact, cascading impact of a tropical storm that has direct impacts, but in different sectors, and then also cascading further into indirect impacts. We are trying to bring many of the historical events together so that users can learn from other areas, say, how did a multi-hazard event cause impacts through a system, and that they could use that also to better plan that for their own area. So here you see a small example of one of the real ones. We have brought them together in a kind of wiki environment where it's possible to query them and to consult them better. We're also working on methods to better characterize specific disaster events in terms of how long did they take place and how big their impact was, so that we could make that also in relation with a improved disaster database. We are also discussing with different say organizations to make suggestions to improve disaster databases. Say one of the main tools that we are developing currently is also we have developed is on hazard assessments and risk assessments. Here an example of one of the tools for rapid hazard assessment is called Fast Flood. It's an online tool that allows people to generate flood maps for any part of the world by simply selecting an area, downloading global data sets, or replacing them with more higher resolution data, and through that being able to analyze and simulate flood events in a very rapid way. And this can be also used to modify situation by developing mitigation measures and then seeing how these mitigation measures would impact the flood events. here an example of how that is being done. For example, for developing like an embankment, we can then sketch what would be the effect of the development of that embankment, and we would immediately see how that results in improvement or not. So it's a planning tool to see for stakeholders how quickly we can adjust or evaluate what different planning options are there. So this tool has been is one of a series of tools that we aim to develop for different applications. We can have applied it also in very different areas, both for coastal flooding as well, or for dam break flooding or flash flooding. We also developed a similar tool, which is for mass movement, for landslides, which allows to analyze for any mountainous part in the world where landslides might initiate and where they might run out. And this is also a fast method that is very helpful in designing mitigation measures, but also in terms of early warning. We bring those tools together in a loss estimation tool. It's called Risk Changes, which integrates the hazard information with elements at risk, so the buildings, the population, the roads, or whatever other information, and vulnerability data with administrative units, and allow to estimate how much of the elements at risk would be exposed, so how many buildings would be flooded, but also what would be the expected losses of individual events and the combined risk information. So we have that also as an online tool developed, which can also be used to analyze the effect of climate change and other future changes, and also the changes in terms of risk reduction. So you can test out what would be the change in risk if we do a certain development in an area. And that could be the basis then for cost-benefit analysis for further analyzing this. Finally, we are using also collaborative mapping tools. So where different stakeholders come together, they evaluate the situation within an area, and then they consider different risk reduction options, for example, by engineering works, or by ecological measures, or by evacuation planning, or any other tool. And through this series of softwares, they would be able to analyze what would be the effect of those interventions, and they could also visualize that in 3D within their area. So this
Thank you.
So one more. I have two more slides before finishing. So one of the guiding questions here is, which method is best for multi-hazard risk assessment? And so we want to guide, say, end users that work at different scales, at national or lower scales, for different purposes and different types of hazards, also with different data availabilities, and also changes over time, to suggest what methods, what approaches would be best in which situations. So we have developed also stakeholder environment, a stakeholder hub for our projects. We would invite you to register for those, and also see further the results of our project, which still takes 2.5 years. So thank you very much for your attention.